Okay, this is our first video where I'm going to actually be showing you how to do calculations. And you've received this notes page here, and the first thing you should do is take this calculations part, cut it out, and glue it in your notebook so that it looks kind of like this glued in. You should have your page number on there, and this just tells us the steps for working every engineering problem. You need to draw a picture. Sometimes the pictures are going to be given to you like these. If you're given the picture, you don't have to draw it. List the knowns and unknown quantities. That's the information given in the problem and what you're looking for. A lot of the time, you can put this information right on the problem, and you don't have to write it out separately because it's going to be on your picture. You should write the formulas each time. Remember, when you put stuff in your engineering notebook, you're proving what you're doing. You're doing it so someone else can follow your work. So you need to write the formula down, substitute in the numbers, solve, and then check. When you check, think, is it reasonable? Did you put units on, and did you do a good job at rounding? So you should take your first example here and glue it into your notebook. And we're going to be writing our information underneath it. So you need to cut this one out and then have some space so you can show your work. Don't glue the rest of them in until you know how much space you need to leave to show all your work there. So here we are, and instead of trying to do it on this page, I'm going to just go ahead and show you on the slides, but they're the same exact as what you have here. So here's our first problem about a lever. And it's already got the picture drawn for us, which was step 1, so we don't have to draw a separate picture. And then we're going to list the knowns and unknowns. Well, in this case, they're already on my picture, so I just need to label them. Effort, that's E for effort, and this force going down here in 16 pounds, that's my force effort. Then the 32 over here, this is my force resistance. This is also known as your load. The load is always the force resistance. This distance here is my distance effort, because it's the distance from the fulcrum, this is the fulcrum, to my effort force. And on this side, this is my distance resistance, from my fulcrum to my resistance load. Okay, now you need to write out the formulas we need. We have MA equals dE over dR. That's the distance to the effort over the distance of the resistance. And we have MA equals the FR over the FE. Do notice these are swapped, the R and the E on each one of these, so you get them in the right order. We don't need to worry about which one is the ideal and the actual, because we're going to assume that all of these are 100% efficient. So in this case, this MA is going to be equal to this one here. So we can also write this as dE over dR equals FR over FE. Sometimes we're going to need one of these, and sometimes we're going to need this one. So the first thing it asks us to do is find the AMA, which is this one with the forces, and then it asks us to find the IMA, which is the ideal mechanical advantage, which is the one with the distances. So we're first going to use this formula here to find this one. So I'm just going to rewrite it. Our next step is to substitute in the values. Do we know FR and FE? Yes, we label them right here. Here's FE and FR. I need to put them in. And FE is this one. And you'll notice that our units cancel out here. And if I divide this on my calculator, I'll get 2. Notice that MA does not have any units in my answer. It just means that this is 2 times easier to push down here than it is for what's on this side. That means that I have to push down less. Now for the IMA, I'm going to do the same thing, but now I'm using this formula. I'm going to copy it down one more time. And I'm going to substitute in these numbers up here. DE is 5 inches. and the dr is 2.5 inches. Notice the units cancel, and again, if I divide this on my calculator, I get a MA of 2. These numbers should be the same if our efficiency is the same. What would have happened if one of these numbers here was given in feet and one in inches? That's right, you'd have to change the units so that units are the same so that they'll cancel out. Okay, our next problem. Glue the next one into your notebook, and then take down these notes. Here's our problem. And this time, again, they've drawn a picture for us. So we have step 1, draw a picture is done. But we need to label the knowns and unknowns. So here's where, and it didn't tell me which was effort and load. So if I look, this is where they're saying this is a force pushing down, and this is the load of bricks on this side. So this side is my force resistance, or my load. That's the part I need to move. And this is my effort force where I'm pushing down on it. So this 3.6, this is going to be my distance to the effort. And is 5 my distance to the resistance? No. My dr is going to be this distance right here. How do I find that? Well, I need to subtract these two numbers and then fill it in right here. So I can use my calculator for that, and I'm going to find it's 1.4 meters. Then I want to write down my two formulas. IMA equals DE over DR. AMA equals FR over FE. And then I'm going to look at my problem. What is the mechanical advantage of the system? Well, which one do I need to use? We can use either one because they're going to come out the same. Do I know enough to use the forces and find this one? I don't, because I don't know the effort force. But I do know the two distance, so I can use this formula here. So I'm going to write it up here. My DE is 3.6. My DR is 1.4. Notice the units cancel. When I divide, I get 2.57. That's my mechanical advantage, 2.5 times. Now, what force is required? Well, now I know that the IMA is equal to the AMA, and I know the resistance, so I can find the FE. So I'm going to write this formula down. AMA equals FR over FE. I know AMA is the same as this, so it's 2.57. I know the resistance is 15 kilograms. And I'm looking for F, this F I started with. So how do I do that? You can think about cross-multiplying, or you can think about solving this for an unknown by multiplying both sides times F, whichever way you like to do it from algebra. And what we get is we get this times F equals 15. I'm going to write it out the first time here. And then how do you solve it? You divide by this side here. So we get F equals this when I divide it. And we get 5.83. And what are the units on that? Well, if I look at my units I had here, 15, this was kilograms. This didn't have units, so kilograms divided by no units gives me kilograms. And then it says, well, what mass would I need to put on this side so that it balances out? Well, hopefully you see that if it takes this much to hold up this side, that this is also the answer to part C here, and it's 5.83 kilograms. Okay, and our last example. Here's our picture right here. So I don't need to draw a picture. I'm just going to put my labels on here. Newtons is the metric units for force. So this is my load force. So this is my force resistance. And here's my effort. This is my force effort. And it doesn't tell distances, so let's go up here and read it. And up here it says, Susan and Jake, their truck is stuck, so they need to push this up so they can get it out of the mud. And what is the mechanical advantage of the tree branch? So let's write out our formulas. IMA equals DE over DR. AMA equals FR over FE. Which one of these formulas do we need to use to find this mechanical advantage? Well, since they haven't told me anything about distances yet, the only thing I know is this one right here, so I'm going to use that one. FR is 2100. FE is 700. Units cancel. And we get 3. Mechanical advantage of 3. Now on the next one it says if the bumper is 1 foot and 3 inches from the fulcrum. So that's right here. Here's my distance they told me in the problem. This is 1 foot 3 inches. And if you don't know, this means 1 foot 3 inches. That's what those little symbols mean. And then it says, where must we push down? What is this distance? So this is my distance to the resistance, and I'm looking for the DE. So now I can use this formula. I know the IMA is equal to the AMA. I know the DR, so I can find the DE. So I'm going to write it down. IMA, that's the same as this, 3. DE, I don't know that. DR, I know is 1 foot 3 inches. But can I put that into a formula in my calculator? No, I need to either convert this all the way to inches or all the way to feet. 1 foot 3 inches. How many inches in a foot? Well, this would be 12 inches in 1 foot. So if I do 12 inches from here plus 3 inches, that would give me 15 inches. Or I could go over to feet, and I could say that this is 0.25 of a foot. So I could also say that this whole thing is 1.25 feet. You learned how to do those conversions last year. If you don't remember, I can help you out individually. So I'm going to choose to do it in inches, 15 inches. If I choose inches here, that means that my answer that it gives me will be in inches. So again, I can think about cross multiplying these or just multiplying times the bottom. So I've got 3 times 15 inches equals DE. And I find that I need to have this length at least 45 inches so that I can lift the back of the truck. Okay, that's it for the examples on levers. Go ahead and get the workout problems from Ms. Simpson and work those out for your grade.